Hi, Miss Medicine. My name is Damon Vincent, and I will be commencing my presentation on Advanced Function Mid-Unit Assignment for Unit 3. So question 1, describe what happens to the domain and range of a logarithmic function under a vertical reflection. Support the explanation with diagrams. So here we have my original function of y equals log x. Domain and range are x to the real numbers, x is greater than 0, and y to the real numbers. And this is the vertically reflected function of y equals negative log x. The domain and range remain the same, x to real numbers, x greater than 0, and y to real numbers. So judging from the data which was presented, we can determine that there is no change towards the domain and range of a logarithmic function under a vertical reflection. Question 2. Describe what happens to the domain and range of a logarithmic function under both horizontal and vertical translations. Support your explanation with diagrams. This is my original function of y equals log x, domain, range, x to real numbers, x greater than 0, and y to real numbers. I'll be applying a horizontal translation towards the logarithmic function. Horizontal shifts can occur into either a shift to the left or right. For this graph, I will be horizontally shifting the function to the left. Thus, the new function will be log y equals log bracket x plus z, where my asymptote will be z. So this is the horizontally shifted function to the left. Asymptote is z, function log bracket x plus d. Domain and range has been altered, so domain will be x to the real number, x is greater than z, and range will be y to the sets of real numbers. Now I will be vertically shifting the horizontal translated graph by d units. Thus the new function will be y equals log bracket x plus z plus d. So this is the vertically shifted graph where the function is y equals log bracket z x plus z plus d. The asymptote is still the same, and the domain and range has not been altered, still remains the same. X to real numbers, x greater than z, y to real numbers. So from the graph, we can conclude that when a logarithmic function are both under horizontally and vertically translated, the domain will be affected, however, the range will not be affected. Question 3. Graph the function of fx equals 1 over 2 log x minus 4. We'll be doing a and b on the same graph. So graph the line y equals x on the same grid. So this is my function of y equals 1 over 2 log x minus 4. These are the points that I've made out of x and y. X will be 1 here and negative, and y will be negative 4. At this point, x will be 3 and y will be negative 3.5. B. Graph the inverse function of the inverse fx by reflecting fx in the line y equals x. So this is the inverse function of the graph of y equals 1 over 2 log x minus 4. As you can see, the points have been altered, but it is still the same, as this is inversely reflected from the function fx to this. The points are switched from x and y. So now x is negative 4, y is 1 for this point. And for this point, x is negative 3.5 and y is 3. C. Determine the domain and range of the equation of the asymptote of inverse fx. 3c. Domain and range. X is equivalent to the set of real numbers. Range y is to the set of real numbers. Y is greater than 0. And for the asymptote, y equals 0. D. Determine the equation for inverse fx. So this is an equation for the inverse fx. 1/2 log x minus 4. We let y equals 1/2 log x minus 4. We bring the 4 over to the other side. And we take 2, bring it to the other side, which is 2 times bracket y plus 4 bracket equals log x. And once we get our little equation, we take a log and we bring it to over the other side, which is equivalent to 10 to the power of 2 times bracket y plus 4 bracket. And now we just change it back into the inverse fx. Thank you for your time, Miss Madison.